right, folks, what we're going to talk about today is a technique called linear regression. Linear regression. Now, don't get hung up with the phrase, just know that it's called linear regression. And as you learn more about statistics in future statistics classes, the idea of regression, it'll start to make sense to you. But it's just one of those things that today I'm just mainly going to teach you the basic concept and how to do it. And then over the next couple classes, we're going to dig deeper into linear regression. And hopefully by the third class, you may have a better understanding of why it's called regression. Okay? All right, but here's the idea, is that when we have two variables that may be related to each other, they seem to be correlated. Okay? So let's say that we have, let's just call it, we have a variable x and we have a variable y. Okay? And we measure a bunch of people on variable x and variable y, like height and weight, or let's say their vision, how strong their vision is versus how good their driving is, or how much money they have versus how many cars they have, or something like that. Okay, so we have these two variables, and when you measure one person, they measure really high on x and then kind of medium on y. Then you measure the next person, and they're kind of high on x and maybe medium, a little bigger than medium high on y. And then you measure about 20 other people, and this is what you wind up with, is you wind up with this scatter diagram of a whole bunch of input-output points, a whole bunch of points along the graph. They're not perfect. They might be kind of correlated, but they're definitely not in a straight line, okay? This is a scatter plot, okay? And one of the reasons that data comes out as a scatter plot is because there's all kinds of weird reasons why relationships between variables aren't perfect. But what we have, well, I say we as humans, what we as humans have developed is a way of sort of boiling all of these crazy dots down into a single linear relationship. And what we can do is we can take all these points, put them in Excel or in SPSS or in a TI-84 calculator, and we get a straight line. And what we call this line is the regression line. And some people think of this line as what is called a predictive line. Like if we put one variable in, we'll get the answer for another variable. Kind of like a linear function. Actually, it's precisely what it is, a linear function in math. So let's say that given all these dots, we wind up with a regression line that does something like this. Okay? And just like any other line, it'll have a y-intercept and it'll have a slope, right? And we don't know what the slope is right now. Okay? Now here's the interesting thing. This line actually, this dot right here is on the line. But all these other dots, they are not on the line. And typically what we say is this, is that the dots that are not on the line, the reason they're not on the line is because of error. Okay? And you'll learn more about error in future statistics class. I'll talk about it a little bit more. But here's the basic idea, is that if I follow the line only, and I input this x value right here, so let's call this x sub 1. If I plug in x sub 1, the y value should be right on the line, and I should get y sub 1, right? Well, why is y sub 1 here? But look, here's this dot up here. This dot seems to have the same value as this x, right? How come that dot isn't on the line? Well, this little bit here, the reason, this deviation from the regression line, that's the error. And sometimes that error is for reasons that we can't explain and may never be explained. We call that random error. But it's possible that if we investigate into more variables, if we investigate further, we might be able to explain why that error is there, in which case we call it systematic error. Okay? But don't worry about that too much. I just wanted to mention that. The idea here is all we're going to do today is I'm going to teach you how to create this regression line, how to find the parameters for that regression line using Excel, okay? But before I do that, I want to tell you what we call this line. See, in math, we define a line as y equals mx plus b, right? Where m is the slope and b is the y-intercept. In statistics, instead of calling it y equals mx plus b, we call it y, and then we put this little thing over top of it, and we call it a hat, like it's wearing a party hat. Hello, welcome to the party. So we call this y hat. We say y hat, okay? So in this case, instead of y equals mx plus b, it's y hat equals mx plus b. All right, well, hang on. We don't leave it like that. That's how we do it in math, mx plus b. In statistics, we switch it around. Instead of mx plus b, it's y hat is equal to b plus mx. We'll typically put the y-intercept first and then the slope with the variable second. But hang on, there's one more change we're going to make. Y hat, instead of using b for the y-intercept, oftentimes we'll use the letter a instead. So y hat is equal to a plus, and instead of using the letter m for slope, we'll use the letter b. I know that's really confusing because we just took the b out over here, but that's what we're going to put here, bx. bx. And what we wind up with is, in statistics, or in this statistics class, and many other statistics classes, is the form for a regression line is y hat is equal to a plus bx. And what I'm going to show you how to do in just a few minutes is I'm going to show you how to identify the value of a and the value of b given a data set, given paired sets of data, x and y, okay? All right, so what I have over here is I have a set of data. I have x values and I have y values. And what I want you to do is I want you to put those values in two columns in Excel, okay? Let me go ahead and blow it up for you so you can see it better. All right, so hopefully you've already put it in Excel, and now we can do our linear regression. I'm going to go ahead and mute the projector for a couple minutes, and I'm going to write out the procedure for getting your regression equation, okay? The first thing you're going to do, the very first thing you're going to do is you want to enter the data in columns. Okay, so you want to enter your x and your y data into columns. Hopefully you've done that already. All right. Second thing you're going to do is you're going to click on Data Analysis, which is under the Data tab, and you're going to choose Regression. You're going to choose Regression, and then you're going to click OK. Once you've chosen Regression, the next thing you're going to do is we've got input y range, and then step 4, we have input x range. Let me talk about this for a couple minutes before I show you how to do it. Excel uses y as the output and x as the input. But I need to tell you how to select these to put them into Excel. What if you were asked the question, you might be asked the question, what is the predicted value of the variable f when the variable r is equal to 14? What is the predicted value of f when r is equal to 14? Well, this question is implying a few different things. The first thing it's implying is that we have two variables, f and r, and that they are related to each other somehow. And then the last thing it's implying is that one of these two variables is the input and the other variable is the output. One of them is the x value and one of them is the y value. And here's what I'm telling you, is that whichever one you are predicting, so in this case we're predicting f, that means that f is the input y range. And one of the variables we are given a number for. So whichever one you're given a number for, that one is the input x range. So when we have two columns of data, if we have f and r, and we have a whole bunch of numbers, number, data, right? Another numbers, data, numbers, data. Okay? What I'm saying is that all these numbers right here under R, those are going to be put in as input X range. And these numbers over here under F are going to be put in as input Y range. Because in the question, we're predicting F. And we're always, in Excel, we're always predicting Y. So predicted always goes with Y, and whichever variable you're given a number for, that's automatically the X variable within Excel. Okay? Had to get that out there because I'm about to write something here so that you can understand which thing to choose. What will happen sometimes, let me just give you one more example of this, is it might say, your question may say, what is the predicted value of sales when when 5 calls are made? In this case, calls is given a number, which means calls is the input X range, and it says what is the predicted value of sales? How many sales would you expect? That would be input Y range. So you're not always given your data. When you're given data or when you collect data, it's not always given to you as X and Y. So you have to make this decision and know which one to put in for input Y range and input X range. It doesn't help at all, that Excel called both of them inputs, but they're not inputs. The reason that word input is here in Excel is it's telling you to input numbers into Excel. It's not calling your data an input or an input variable. Okay, it's saying, hey, why don't you input some numbers into Excel for me? Okay, that's why I wanted to clarify this for you. Okay, so in Excel, whenever you see the letter Y is always talking about an output variable or a predicted variable. Whenever you see X, it's referring to an input variable or a given number variable. Okay? So here's what you're going to do. Under input Y range, you are going to select all data for the output variable. And then for input X range, you're going to select all data for the input variable, which is the one for which you are given a number. Okay? So that's steps 3 and 4. All right, now let's go on to step 5. Under output range, what it means by output is where do you want Excel to put your results from the analysis. And you're just going to select any cell. Select any cell and press enter. And then step 6, you're going to click OK. And after you click OK, you're going to get a whole bunch of stuff. Excel is going to give you a lot of information, but you only need 2 of those pieces of information. One of those pieces of information, remember, y hat is equal to a plus bx. One of those pieces of information is the a, and the other piece of information is the b. Now, you just put all that data into Excel. Let's go ahead and run the analysis now. All right, let's erase some of this stuff. Oh, and before we do this, let's go ahead and ask a question. Let's say for this particular data, let's say what is the predicted value of y when x is equal to 11. All right, so I'm going to go over to my computer. Let's go ahead and turn on the projector here. All right, you can see here. I'm going to put the data right down here. I'm going to go over to my computer. I'm going to click on Data, then Data Analysis. And I'm going to select Regression. I got to scroll down on the side here. And do you see this in the box? It says Regression. It's below rank and percentile, and it's above sampling. And I'm going to click OK. It gives me this box here. And now you can see it says Input Y Range. I'm going to click on this thing over here, and I'm going to select all the data for the output. Press Enter. And under Input X Range, I'm going to click on here and go to the input data. Press Enter. You don't have to click any of these boxes here, but go to Output Range right here, and I'm going to click on this, and I'm going to put the data maybe in this box right here. Let's say right here. Press Enter, then click OK, and ta-da! Look at all this stuff. That's a lot of stuff. I'm going to scroll down, and I want to show you over here. This is the information that we want. Okay? This is the information that we want. Intercept. Intercept is the A, and X variable, there's a 1 here too. It might say X variable 1. That is the B. And these are the coefficients. See, this A and this B, those are coefficients. And in this case, the A is 63.974, and the B is 0.768. And therefore, our regression equation is going to be y hat equals A 63.974. And because this is a positive number, we're going to put a plus. If this was a negative number, we would put a minus. We're going to put a plus 0.768. And then we're going to put an X, BX. Turn this off. And so this right here is the regression equation. So if you're asked what is the regression equation, that's the regression equation. And now it says, what is the predicted value of y when x is equal to 11? Well, all you have to do is plug 11 in for x. So I'm going to get a calculator now. I have one lying around here somewhere. Just use it. Here it is. All right. So I'm going to grab the calculator and I'm going to key in 63.974. 63.974 plus 0.768 plus 0.768 times x. But in this case, x is 11. So I'm going to put here times 11. And now I press enter and I get 72.422. So I'm going to say y hat equals 72.422. That is the predicted value when x is equal to 11. Now, does that automatically mean that for a particular person, that if their X value is 11, that their Y value will automatically be 72.422? No, it doesn't. This is the predicted value of Y. The actual value of Y could be 74 or 80 or 68.2 or something like that. And any deviation from 72.422 would be accounted for by error, either our error because it's systematic and we didn't account for something important, or random error, which is error belonging to the universe and we don't know why it was different than what the predicted value is. Okay? Let's do another example. All right, so we've got another question here. Now we're going to have new data. Don't use the last data. Don't use the linear regression formula that we just had. I'm going to give you some new data. But this says, what is the predicted value of Y when X is equal to 8? Okay? And let me go put up some new data for you. All right, so we've got some data here. What I'm going to do is I'm going to go ahead and put this up on the screen for you. And now that you have it in Excel and I have it in Excel, we can go ahead and do our linear regression. So I'm going to go over to my computer right now, and I'm going to click on Data, and then Data Analysis. Then I'm going to go to Regression and click OK. Now I'm going to clear out this information. I'm going to go to Input Y Range, and look what I'm predicting. It says, what is the predicted value of Y? So I'm going to put the Y data in for Y, and then I'm given a number for X, so I'm going to put the X numbers in for X. So that's convenient. So I'm going to go to Input Y Range, and I'm going to select all these Y values, press Enter. Then I'm going to go to Input X Range, and I'm going to select all the X values, press Enter. And then down here on Output Range, I'm going to click on Output Range, and I can select any cell. So I'm just going to select something maybe right here, press Enter, then click OK, and here are the coefficients down here. I'm going to go ahead and zoom into those, and you can see, let's go this way, that our intercept is, our A is 32.554, and our X variable is negative 2.144. Okay, so that means that our regression equation is Y hat equals A, the intercept, 32.554. Now, because this is negative, instead of putting a plus, I'm going to put a minus. Minus 2.144. 2.144, and then just an X. And this is now our regression equation. And so we can now answer the question, what is the predicted value of Y when X is equal to 8? All I have to do is put an 8 right here in for X. And I'm going to do that in a calculator. So grab a calculator. I'm going to key in 32.554 minus 2.144 times 8, and I get 15.402. So Y hat equals 15.402. Okay? And what if I now asked a different question? What if I said, what is the predicted value of Y when X is equal to 5? I can ask a million questions. Well, now I'm going to plug 5 in for X, and I'm going to get a different number. I'm not going to get 15.402. Well, I'm probably not going to. So I'm going to go 32.554 minus 2.144 times, instead of 8, now I'm going to do times 5. And I get 21.834. So Y hat is 21.834. So we can predict hundreds of different things. What is this useful for, Mr. Ryan? It's actually useful for quite a bit of things. In the medical field, if they know that there's a strong relationship between 2 or 3 things, they can create a formula where you enter in information about the person's heart rate, their blood pressure, their blood sugar level, and you can determine things about their health condition based on a regression equation. So plug in blood sugar level, and then we know what likely, maybe, what their, I don't know, whatever level is, their likelihood of being diabetic or something. I don't know. One thing you could do is we could predict, sometimes what they'll do is you can maybe predict how tall a person is going to be when they're 18 years old based on how tall they are now at age 11 or something like that, or how tall they are at age 6 or 7. It's basically just a linear formula. Now, this is linear regression. I am not going to cover another kind of regression, but you could do quadratic regression, you could do exponential regression, you could do logarithmic regression. There's several different kinds of regressions that you could do. It doesn't have to be fit. Doesn't have to be fit to a straight line. It could be fit to a different, you could do cubic regression or quartic regression. But in this class, we're only doing linear regression. So let's just do one more example, shall we? All right, what I'm going to do now is I'm actually going to give you 3 sets of data. It's going to be 3 columns instead of only 2 columns. Okay? What I want to show you is that you can be given multiple columns of data, but then create a linear regression that is only between 2 of them. Okay? Let me show you what I mean. Okay, so look here. We've got this, we've got X, and we have Y, and we have Z. Let me go ahead and take this data and put it up so that you can enter it into Excel. All right, so hopefully you've got all that in 3 columns in Excel now. And here's what I mean by this, is we can now create a regression equation between X and Y, between X and Z, or between Y and Z. And when we create those regression equations, we can do X as the output and Z as the input, or we can do X as the output and Y as the input, or we can do X as the input and Z as the output, or X, you know, basically there's 6 different possibilities that we have. Okay, so what I'd like to do here is, let's look at this question. It says, what is the predicted value of X when Z is equal to 50? And in this case, our X is actually the output value. That's the one that we're predicting. And the Z is the input variable because that's the one that we're being given a value for. And what that means is that in this particular case is we're going to put the Z data in for the X's and we're going to put the X data in for the Y's because we are predicting what the value of X is. Okay? And so let's go ahead and try that. So we got the data in, and now we're going to go do our linear regression. So I'm going to click on data, then data analysis, regression. I'm going to delete the previous information. And now where it says input Y range, here's what I want to remind you. Input Y range, what we put in there is whatever we are predicting. What are we being asked to predict? And in this case, we're being asked to predict the value of X. So we have to put the X data into input Y range. It doesn't matter that Excel is calling it Y. We would say input X range. And then under input X range, we would put in the Z, because Z is what we're being given a number for. That's our input variable. Input variable, output variable. And what Excel really means is, it means, instead of saying input Y range, what Excel actually means by that is, tell me all the data for your output variable. And then here, it really means, tell me all the data, or where do I go to get the data for your input variable? That's what it's really asking. And since X in this case is implied as our output variable, and Z is implied as our input variable, we're going to put the Z data in the second box and the X data in the first box. So for input y range, I'm going to grab all the x values. Oops. Press enter. And then for input x range, I'm going to grab all the z variables, or all the z data. Press enter. Under output range, I'm just going to select an arbitrary cell. And then I'm going to press OK. And now I'm going to scroll down, and here are my coefficients. These are the coefficients that I need. This is the A, and this is the B. And so A is 14.308. So our regression equation technically is going to be x hat. That means the predicted value of x is equal to 14.308. And because this is negative, we're going to put a minus 0.169. And then our input here is z. And now we could use this to plug in 50 and calculate the predicted value of x. So in this case, x hat, our predicted value of x, is going to be equal to, let's grab a calculator. We're going to key in 14.308 minus 0.169 times whatever the z value is, which is 50. And we get 5.858. 5.858. That would be our answer. Okay? So, you're probably going to need a good bit of practice on this. The worksheets that I give you, they look like this. The first one is really easy. It's just very simple, a bunch of x and y coordinates. You give me the regression equation. You plug in one number for x and get a y. Plug in another number for x and get a y. But then on the back, it becomes a little more complicated. Instead of giving you x and y, I give you actual real-life scenarios. With this one is square feet of a house and the price of the house. This one's exercise versus related to heart rate. Here's education beyond high school compared to yearly income. Then I've got this bigger worksheet where I give you 3 columns of data. You see this? This is about cars. Okay, how old the car is, how many miles the car has, and what the price is because it's for sale. Then on the back we've got houses. We've got how many bedrooms the house has. We have how many square feet the house has. And then we have the price of the house. And they're probably all related to each other. But these questions that I'm asking, in addition to asking for the regression equation and predicting the values of the variables, up here on these first 3 questions, one of the things that I'm asking you to do is to go back to the last lesson we did, and you're identifying the R correlation, and you're doing a hypothesis test on the R correlation. So these first 3 questions are really just review for something that you already learned, but I want you to practice so that you can remember how to do it. Okay? All right, well that's it. That's all I have for you. This is linear regression. It's only the first day that we're doing linear regression. We're going to, over the next couple classes, we're going to do more linear regression. So you'll have lots of practice doing linear regression over and over and over again, and identifying your A and identifying your B, and then plugging values in to get predicted values. Okay? All right, well that's it, and I hope you have a good day.